Alright, so for number 2 we want to find the Laplace transform of this function. There's a couple different ways to do this, but I'm going to do it by letting f of t equal the function that we're trying to find. Okay, and we haven't, we don't know a formula for this right off the top of our heads, and we don't want to use the definition because that would be kind of a messy integration. So what can we do? We can take the derivative. F prime of t would be, by the product rule, it would be e to the at plus at e to the at. Okay, so if I take this derivative formula here and then apply the Laplace transform operator to it, okay, so the Laplace transform of f prime of t is going to be equal to the Laplace transform of e to the at plus, and then remember, Laplace operator is linear, so I can, it's going to be the Laplace transform of this plus the Laplace transform of this, and here I can factor out the a, so it's going to be a times the Laplace transform of t e to the at. Okay. All right. Now we know how to handle this, right? This, the Laplace transform of a derivative, it's equal to s capital F of s minus f of 0. Okay, and that's going to be equal to, now, Laplace transform of e to the at. That's a well-known formula. That's just 1 over s minus a. And then we have a, and then the Laplace transform of, now notice, what is this? This is the Laplace transform of the original f of t, which is capital F of s. Okay, so what we're trying to find capital F of s. So we've got it here and we've got it here. All we got to do is get those terms together algebraically and isolate it. One nice thing is that little f of 0 is 0, because you can just see that if you plugged in 0 here, you'd have 0 times 1 is 0. So you have s capital F of s is equal to 1 over s minus a plus a capital F of s. I'm trying to solve for capital F of s, so let me just subtract this term over, or subtract it from both sides. So you'd have capital F of s times s minus a is equal to 1 over s minus a. So capital F of s would be, if I divided both sides by s minus a, I'd have 1 over s minus a squared. And that's it. That is exactly the thing we were looking for. That's the Laplace transform of t e to the at.